Hello, everyone, and welcome to the OneClass channel. My name is Donna Riel, and I'm a recent master's graduate from the Material Science program from the University of Ontario Institute of Technology, also known as Ontario Tech University. So today we're going to go over some commonly asked questions in chemistry at the high school, college, and university level. So if you needed any help with homework or with tutoring, then check out the links in the description below. So now I'm just going to get started for our questions in today's session. Okay, so question 1 asks, is the process of liquid water turning to ice endothermic or exothermic? Explain what is occurring using the terms system, surroundings, heat, potential energy, and kinetic energy in the discussion. Okay, so before we answer this question, let's make this like a comparison table for endothermic and exothermic. Big. Okay, so during an endothermic reaction, heat is absorbed from the surroundings to the system. So this is the same thing as saying that heat is a reactant. Also with endothermic reactions, the sum of enthalpies of products is greater than the sum of enthalpies of the reactants. So this can also be expressed using these variables, where the sum of the enthalpy of the products is greater than the sum of the enthalpy of the reactants. Okay, so now let's look at exothermic reactions. So here, heat is given out to the surroundings. And this is from the system. So this is the same thing as saying that heat is a product. Similarly, the sum of the enthalpies of the products this time is less than the sum of the enthalpies of the reactants. . I'll also note that for an exothermic reaction, the delta H of reaction is less than 0, so that means it's negative. And in endothermic reactions, the delta H of reaction is greater than 0, so it's positive. So the question asks if the process of liquid is endothermic, of liquid turning to ice is endothermic or exothermic. And this is actually an example of an exothermic reaction. So I'll just write it in the column for exothermic. And let's draw like a little diagram. So this is liquid water. That's is frozen to solid ice. So the reason this is exothermic is because the system loses energy which is transferred to the surroundings in the form of heat. So if we think about the opposite of this reaction, turning ice into liquid water, in order to melt the water, heat needs to be added. So that's why solid melting to ice is an endothermic reaction, because heat is a reactant. But in this case, when you have liquid turning into ice, that energy loss is transferred to the surroundings in the form of heat. So we can also draw a potential energy diagram. So I'll draw it at the bottom here. So this is the potential energy diagram of liquid turning into ice. So this is a plot of potential energy. And then this is the reaction progress or coordinate. So let's say the energy of liquid water starts like here. The plot would look like this. So this little hump here is referred to as the activation energy. This is how much energy needed to be added for the reaction to take place. And if you notice, our reactant is at a higher energy than our product. So we can say here that heat was released. Okay, so that's an example of an exothermic potential energy diagram. So let's just compare it to what a potential energy diagram would look like for an endothermic reaction. So just drawing the same diagram. Let's say we wanted to melt ice. It will look like this. So you'll notice that our reactant this time is at a lower energy than our product, which is water. So I can label this as heat being absorbed. Again, this is just activation energy. Okay, so let's see what the junior tutor said. An exothermic process releases heat, causing the temperature of the immediate surroundings to rise, while an endothermic process absorbs heat and cools the surroundings. We consider the sample of water as our system. Freezing is an exothermic process. This is because energy moves out of the water towards its surroundings, which technically makes the water particles lose kinetic energy, making them move slower and slower as freezing takes place. Okay, so the question asks for terms using system and surroundings, which is what the junior tutor said. They mention heat and kinetic energy. Yep, the solution's still correct. Anyways, even though potential energy, that the term wasn't used, but it was still a very detailed and in-depth explanation.